Hey, I'm good, I'm good.
How have you been?
Yeah, I'm good. I was recently watching the episode of the Into the Minds by your
Ah.
team. It's really,
Yeah.
really a nice concept.
We've been trying to do a couple of interviews with researchers
Yeah.
and trying to get what they are working on.
Yeah.
And we've been trying to put it in a very simple way so that it's easier for the audience to grasp it.
Yeah.
So I mean, if I were to ask about your work right now, how would you describe it?
Yeah. So my PhD work revolves mainly about butterfly coloration and how it functions against predators. So it can be broadly divided into two sections. So the first section deals with how the butterfly uses environmental parameter to modulate its coloration. So here it's not the genomic structure of the butterfly individuals, but rather the butterfly is responding to the differences in the environment, and as a response they are exhibiting in terms of different color types. So this comes under the theme of phenotypic plasticity. And the later part is mainly about the wing shape and the coloration present in certain group of butterflies and how they are related among each other and how it functions against predators. You may as well know that butterflies have various life stages, just like the Drosophila that you're working with. So they have the egg stage, larval stage, pupal stage, adult stage. And this change of coloration as a response to different environmental variations can happen in the larval stage, pupal stage, as well as the adult stage. And my work mainly deals with the pupal stage and the adult stage. So I can first go about how it happens in the pupal stage. The pupal stage of a butterfly is a particularly interesting stage because it's largely immobile. They don't have that much ability to move around. And if you look at predator attacks, so in the predator attacks, the most common response involves movement, either to escape away from the predator or to respond in such a way that the movement will sort of frighten the predator and they can escape. But such level of mobility is not possible in the case of pupa. So what they do is that instead of fighting the predators, they hide. They hide so that the predators do not detect them. So simply saying, they employ camouflage. So camouflage is not just the only strategy that they use, but it is the most common strategy that the pupa use against predators. But in order to camouflage well, so they have to effectively blend in with the surrounding or the background, let's say. They have to effectively blend in with the background so that they are not detected. But if you look around in the nature, the background is so varied. The background can be anything. The green leaves, the dry leaves, the soil. The background, the coloration of the background is very varied. And now, how do this butterfly pupa blend in with the background then? So it turns out, in my study organism, it turns out that the butterflies can modulate their coloration, the coloration of the pupa, depending on which background they are. So if the background is brown in color, they will develop into brown pupa. If the background is green in color, they will develop into green pupa. And they will blend in with the background very well. And earlier studies have sort of grouped this pupil color into two broad categories. Like so it's either green or it's either brown. But what our study has found is that it's not just green and brown. It's rather a continuous color change in the coloration from like dark green, light green, to pale brown, dark brown, like that. And what we have found in our study is that those pupa that were found on the tree leaves, they were pupated on the tree leaves, so they tend to match the color of the tree leaves as well. Because the tree leaves, if you look at the tree leaves, the tender leaves will have more yellowish color compared to the mature leaf. The mature leaf will have dark coloration. So when I looked at it, so the pupil coloration was also very tightly matching the color of the leaf where the pupa was found. So this level of response to the this fine level of response to the background coloration will probably make their camouflage much more effective. So now what happens in the case of the adult butterflies. So in seasonal environment like here, IISER Thiruvananthapuram, we have the dry season, and we have wet season, which is the monsoon, like starting from June to December, and the dry season starting from end of December till April is very dry. There's no rain, so there's a sharp seasonality. And then if you look at the background, now let's come back to the background again. In the dry season, the background is very brown. There's a lot of dry litters, so the background is basically largely brown in color. If you look at the wet season, because the monsoon, all the leaves are flushing, all the trees are like abundant with their green leaves. So the background is very different. The dry season is very brown, and wet season is very green in color. So how does adult butterflies use these environmental differences to modulate their color? So the primary motive is to use the coloration to defend themselves against predator attacks. So I study with a group of butterflies called Michaelisans. So they are also commonly known as the browns because the color of the butterfly is brown in color. So what happens in the dry season, the butterfly is already brown in color, so they can camouflage in the dry season. They can camouflage very well. But in the wet season, if you put a brown thing on a green background, that brown thing is obviously going to stand out. So they do not employ camouflage, they employ something else. So in the wet season, they develop these eye spots, these black circular markings which looks like eye on the edges of the wing, along the edges of the wing. And what this eye spots does is that it dupes the predators into thinking that is where they should attack instead of the real head. And the predators, like the birds, they go into these eye spots, and when they attack these eye spots, these adult butterflies can tear their wing off, and they can fly away, and they can continue with their behavior. And people have shown with their study that the adults with the wing torn and adults with wing intact, they do not show that much difference in their behavior. So two very different strategies based on the environment. And one, in the dry season, they are brown in color, they do not have eye spots, they camouflage. In wet season, they are brown in color, but they have large eye spots on the wing margin, and they deflect the attack towards these eye spots. So now we want to see what factors modulate this presence and absence of these eye spots. In some African butterflies, where there's a sharp variation in temperature in the dry season and wet season, they use temperature as a cue. So they can predict if the temperature is low, for example, they can predict this is going to be dry season, and they develop into these butterflies without a spot, and they camouflage well in the dry season. So likewise here, we looked at the variation in the environmental parameters, like temperature is not varying a lot here because, as I said, it's close to the equator. And then we look at the relative humidity, and the relative humidity is varying a lot, like around 30% variation in the dry season and wet season. So we basically tested if they can use these butterflies that are found here can use relative humidity as a cue to predict the environment they're going to develop into, and if they can use this cue, the relative humidity, to sort of modulate the presence or absence of eye spots when they develop into an adult. And we found that if the Michaelis minius individuals are grown entirely in the low relative humidity setting, they tend to develop into adults without any spot, which is what the dry season individuals look like. And if we rear this completely in the high relative humidity setting, they tend to develop into these adults with this large, conspicuous, very vividly visible eye spots, which is what we see in the wet season. So yes, like these butterfly individuals, when they are developing, they can sense the they can sense the relative humidity, and they can use this relative humidity and predict the environment and modulate whether they're going to, express the eye spots or not.
So it was nice talking to you.
Yeah.
Good to know your work.
Yeah.
Yeah, movement, interesting goes well.
Yeah. Thanks.
Yeah. So are you going to get back to work?
Yeah, I'll go back to work. So I'll probably have to continue the analysis for the last what I was talking about. Yeah.
That's good. Yeah. All the best.
All the best for your work also on Drosophila.
Yes.
Next time I'll ask you what you're working on Drosophila.
Yeah, sure. Okay then.
Yeah, nice to